Going to talk about unit conversions, and the method that we're going to use to solve unit conversions is something called dimensional analysis. This is a really, really important skill in chemistry. It's something that we're going to use from now until basically the end of the semester. So I'm going to go through it nice and slow, maybe painstakingly slow, so that we really get a good understanding of how dimensional analysis works. So we want to lay a really, really solid foundation today. So dimensional analysis, we're going to use dimensional analysis to solve the following types of problems. So how many kilometers are in 456 miles? So here we're going to change from the unit of miles to the unit of kilometers, and this is a really important skill for us to use. The first thing that I want to talk about is a little bit of terminology. It's words that I'm going to use now and then also use it again later in the semester when we start converting between chemical units. So equalities. Equalities show the relationship between two units and they measure the same quantity. So in order to convert from one unit to another, we need to be able to measure those two units in the same quantity. Here's the equality that we would use to solve this problem. 1 kilometer equals 0.621 miles. What does that mean? So if I handed one student a tape measure and it measured in kilometers, and I said, grab this tape measure and run until it reads 1 kilometer, then stop. And I handed another student a tape measure that measured in miles. And I said, grab the end of this tape measure, run until it says 0.621 miles and stop. What you'll notice is those two students will have stopped in the exact same place. They'll look to next to them and they'll see the other student right there next to them. So they ran the exact same quantity, but we're using two different units to measure that quantity. That's an equality. So the key to these problems is to first choose the right equality. The application of the equality is called a conversion factor. So this is simply writing the equality with one number on top and one number on bottom in the form of a fraction. And this is how we'll use it to convert from one unit to the other. This is the application or the math of the equality. Of course, you notice there could be two conversion factors that we can form. So we can put kilometers on top, miles on bottom, or we could put miles on top and kilometers on the bottom. So which conversion factor do we use? The problem will tell us. So once we have the problem set up, we'll know which one to use. Let's dive into this problem together. And again, we're going to go through this very, very slow. We want to lay a solid foundation. So the problem, how many kilometers are in 456 miles? The very first thing you do for any unit conversion that's ever going to come across your paper in this semester is you are going to write down the information that's given, the measurement that was taken. So in this case, the measurement that was taken is 456 miles. So that's the very first thing that gets written down on the paper. Next is where dimensional analysis comes in. So dimensional analysis is let the units guide your problem. So what I'm going to do, I teach the train track method. If you have a method that works for you, and the key word here is it works, you may use your method. This is the method that I'm going to teach and talk about throughout the semester. So if you need to have a new way to solve these problems, this would be a good place to start. So we've got our 456 miles written on our paper. I'm just going to extend this line, draw my little train track. Let the units guide your problem. So the unit that we are trying to get rid of will always go diagonal. So I'm going to divide by the unit of miles. So if I take miles divided by miles, that cancels that unit out. And that's what we're trying to do. We don't want the unit of miles anymore. So the unit miles is going to go down here. On the top is going to be our destination. So what unit are we trying to convert to? In this case, we want to know how many kilometers. So our destination is kilometers. So that's the unit that's going to go on the top. So kilometers on the top. Now my units are guiding my problem. I know what unit goes on the top, what unit goes on the bottom. Now I just need to peek back at my equality to determine what number goes with each of those units. So flipping back to our equality here, here's our equality. I see the number 1 is attached to kilometer. So when I go to my work, I find the unit kilometer is on top and the number 1 is attached to kilometer. Back to my equality, I see the number 0.621 is attached to the unit miles. So on my work where I see the unit of miles, that's where I'm going to write my 0.621. Now I'm set up. To solve this, I will multiply across the top. So 456 times 1. Divide by anything that's on the bottom. So divided by 0.621 miles. So go ahead and grab a calculator and throw that into your calculator. So 456 times 1 divided by 0.621. And here is what my calculator spits out. 734.2995. Now, is that the number that I'm going to report? No. We have to consider significant digits. We have to consider sig figs. What property did we use to solve this problem? We used multiplication. What is our rule for multiplication? It's the weakest link. We go to the measurement that was taken. We always look right here at the measurement that was taken. We never look at the conversion because that's considered an exact number. So in our original measurement that was taken, I see 1, 2, 3 sig figs. So when I report my answer, I will report it to 3 significant figures. So what is the number that I will actually report? Let me get a different color here. The number that I will actually report is 734, and the unit, so miles cancels, the unit is kilometers. So this is what I would report to get all the points for this problem. Here's a table full of unit conversions. The one in your textbook might look a little bit different, but it'll be the same idea. This is something that you should have readily available to you for upcoming quizzes, homework, exams. Unit conversions, you'll need to see this table and then apply them to the problem. So let's try another one together. Go ahead and pause this video. See if you can solve converting 145 pounds to grams. Then hit play and I will walk you through the video. Let's work through this problem together. What is the very first thing we do for every single unit conversion that we're going to do this semester? We write down the measurement that was taken. So the first thing I'm going to write down is 145 pounds. Then I'm going to draw my train tracks, and I'm going to let my units set up or guide this problem. So the unit of pounds is what we're trying to get rid of. So that is going to go diagonal. I'm going to divide by the unit pounds. The unit grams is my destination. That's what I'm trying to get to. So my destination will always go up here on the top. Now that I have my problem set up, I have my units guiding my problem, I just need to go find the equality that's going to apply to this problem. So looking through this table, I see pounds and grams up here. So yeah, there's kilograms in the middle, but you can ignore that and just jump straight from pounds to grams. So I see the number 1 is attached to pounds. So I go back to my work, I find pounds, and I put the number 1 there. And I see that the number 453.6 is attached to grams. So I'm going to put 453.6 up there. To solve, we're going to multiply across the top, divide by the bottom, and write the number down. So 145 times 453.6 divided by 1. And here's the number my calculator spits out. Is that the number that we're going to report? What else do we need to consider? Significant figures, sig figs. Looking back at the measurement that was taken, so this original value that we wrote down, I see that there's 3 significant figures. So in the number that I report, I can only report 3 significant figures. One of 2 ways that can be done. I can simply write 65,800 and my unit is grams. So that's an okay way to report this number. That is acceptable and you will get all the points. But remember, having those zeros at the end of a number can be a little bit tricky. So the best way to report this is to use scientific notation. So I'm going to take this number and I'm going to put it into scientific notation. So scientific notation. So I'm going to move the decimal over until I get a number between 1 and 10. So 6.58. And then I'm going to tell the viewer how many places I moved it. So 1, 2, 3, 4 places. And of course, I'm going to put my unit of grams. So this is the absolute best way to report this number. Crystal clear that it is 3 significant digits. We use scientific notation to hold on to the magnitude of that number. Here are 3 more examples. I will let you work through these on your own time. The reason that I included them in our slideshow is on the very next slide. The answers are built in. So you can work through those problems, think about significant figures, and then get immediate feedback on whether you got the right answer or not. I hope you guys found this helpful. Again, practice this skill. It's something we're going to use all semester, and we want to lay the foundation when we're using units that we recognize like miles and kilometers. When we get to units like moles and atoms, and it's a little bit harder to grasp, it's going to be really important that we have a solid foundation.